Okay, so we're going to talk now about the relationship between potential and kinetic energy, and make sure that you take visual notes. These will be included as part of your rubric. So once again, energy is the ability to do work. And we've talked about the fact that energy can be transformed from one type to another, and the same thing is true for potential and kinetic energy. So potential and kinetic energy have what we call an inverse relationship. So as potential energy decreases, kinetic energy increases. And as the same thing, as kinetic energy decreases, potential energy will decrease. So where potential energy is at its highest, kinetic energy is at its lowest. They're even when they're both at 50%. And then again, when kinetic energy is at its highest, at 100%, potential energy is at 0%. And again, this is an inverse or opposite relationship. And if you watch the bars over here, you can see that it starts out at the top of the hill. Potential energy is at its highest. And as the car rolls down the hill, potential energy decreases and kinetic energy increases. And you can see also that as the kinetic energy is increasing, its speed is increasing and your height is decreasing. So when the car is at the top of the ramp and hasn't started to move, it has 100% potential energy. It's at the highest point. As the cart's height decreases, its potential energy decreases. And as the cart goes down the ramp, its speed increases, causing the cart's kinetic energy to increase. And it's important to note here that the total amount of energy does not change because of the inverse relationship between potential and kinetic energy. So if it had 100 joules of force here, it would have the same down here. It's just a difference of whether it's potential or kinetic. And here's some more examples. Here the soccer ball is at the top of the hill. It's at the highest point. It has not started to move. So it has 100% potential energy and 0% kinetic energy. Here it's at about 75% of the way up the hill. Its potential energy is at 75%. It's decreased. Its kinetic energy is now at 25%. The ball is halfway down the hill. Its potential and kinetic energy are both at 50%. And then we're at the bottom of the hill, so there's zero height, and the ball is moving, so now its potential energy is at 0, kinetic energy is at 100%. If we look at the painter going up the ladder, if we click on the small paint can and we have her climb the ladder, we can see that the paint can has 50% potential energy. And then as we drop the paint can, the potential energy decreases, the kinetic energy increases until it hits the ground. Now let's look at the difference that mass makes. So here we have a larger paint can. So as she climbs the ladder, now we have the larger paint can, we have full potential energy, and watch what happens as we drop the paint can. The potential energy decreases, or the potential energy decreases, the kinetic energy increases. Here are some other examples. So we see the roller coaster as it's at the bottom of the loop. You can see the potential and kinetic energy change. And again, remember that height is a factor, and so that's why you'll see a more kinetic energy at the top of the large loop than at the top of the small loop. We have the same thing down here. We can see the potential energy increasing and the kinetic energy and how they are opposite. They go back and forth. So I want you to remember that there is an inverse relationship between potential and kinetic energy. And remember that mass affects potential energy, and that the total amount of potential energy, or the total amount of energy, doesn't change. It just gets transformed from from potential to kinetic and back again. So make sure you go to Edmodo and take the Edmodo quiz.